Can AI really build enterprise applications from simple prompts? In this video, we'll look at practical enterprise use cases, discuss the strengths and limitations of AI-generated software, and show how low-code platforms help bridge the gap between rapid development and enterprise-grade requirements. Let's dive in.
For 20 years, industrial companies have tried to digitize their operations. But still, production workers are printing paper, ERP projects take years, and AI pilots never scale. But something has changed fundamentally. Software is no longer manually assembled. It is becoming generated. Today, we will look at one question. What if apps build themselves? And how will this impact industrial enterprises when they can build their operational applications with AI-powered low-code instead of manual coding? So what is the situation? Organizations no longer are asking whether to digitize their operations. What they are asking for is how to scale their operational execution with speed, stability, and governance. How does AI change this now? AI changes the game in building software fundamentally, but it doesn't change how industrial operation must run. What do I mean by this? On the one hand, we have the AI coding tools, and we don't need to argue about that. They are tremendously enabling us to generate code much faster. They increase developer productivity brutally, and they lower the barriers for software engineering very, very much. So we see a drastic revolution in how things are built. More apps, faster creation, lower barriers. But on the other hand, this leads to an explosion of the volume of applications we have, and it does not reduce operational complexity. On the other hand, what hasn't changed and what will not change is the industrial operational reality. Industries rely on deterministic execution of workflows that are not governed by hazard or by chance, but that are governed by reliability. They need ERP and OT integration because they still work with different systems and a lot of different machines that need to talk to each other. And they do need operational resilience, which means they cannot risk to simply rely on processes that work today but don't work tomorrow. And finally, they need frontline usability. Worker digitization and worker empowerment in the frontline is still one of the main challenges and needs to be addressed by those solutions. So what is the answer to that? Let's look into that. From our perspective, the answer will be AI-assisted development, but with a low-code backbone. What do I mean by that? First, we take the speed that AI brings to coding, so to speak, the speed of vibe coding, with AI-native development tools with rapid iterations and a very much lower total cost and time to value. But we combine it for the industrial enterprise with two basic pillars. The one is industrial integration. That means we need a platform or tools that deeply integrate with OT and infrastructure. We need security and compliance, and we need scalable governance. And on the other hand, we need that deterministic execution layer that doesn't leave a security and safety of a process to chance. And all these three elements combined together, you find in what we call industrial application or industrial automation platforms that combine the speed of AI coding, the governance that is needed, and the integration required for successful execution of mission-critical processes. Let's look at the details. One level deeper, what does it mean? First of all, we need an operational execution layer that builds all these components. The first one is integration first. So what we don't want to build is some more of those isolated silos of data in the enterprise. We want the systems of records to be the leading systems for those data, and therefore we need an ERP-centric integration across those systems, machines, and the operational environment. Second, we need AI accelerated delivery, and I talked about that already, because by that, the application building will never be of question again, and we will never have to think about that again. It will just be generated. But in addition to that, we do need, and this is where the low-code backbone comes in, we do need a reusable operational framework that allows us to use pre-built building blocks that are governed, that are safe within those applications. So that AI doesn't start from scratch anytime we prompt an application, but it uses things that my organization has approved upon, may it be integrations or workflow parts or UI parts. And then the underlying thing of it is the built-in governance, versioning, auditability, lifecycle control. Who is responsible for the code created and the applications that go into operations? Who signed it off? Who tracks changes? Everything that needs to be in here. And this combined will lead us, give us an answer, and will show us how apps will really be able to build themselves. If we take an example and look at our platform and Gomo, what do? We built this platform for stable and governed industrial execution. The first part is the reusable components. And when we talk about low-code, these components can be big and small. It can be buttons, it can be entry fields, but it can also be big process steps and big templates for certain applications. The second part is governed low-code plugins. This is a part where industry and company-specific processes and parts of applications are built, maintained, and governed. And these are the parts also that the AI uses when building applications. And the third part, very important, is a deterministic process engine. Because companies in the industrial environment, for them, it's not enough if a process is kind of right or approximately correct. They need 100% reliability. And this is why also tomorrow, deterministic process parts and the ability to define those processes in a platform will be integral to industrial operations. If we look at the governance part, how can we execute that? Our take is to include a version management into the platform. That means, I guess you all know Git. It's a Git, but with some twist to it. Of course, it enables a lifecycle management. It enables to build branches. It enables to commit changes and be in control of the whole application lifecycle management. But what it also does is it enables users to get a visual comparison of their changes. So instead of browsing through thousands of lines of code, users can simply compare their old version to the new version and immediately see what happened to their applications. And this enables a guided process in the application building. It brings in governance to that process, and it enables organizations to really scale that AI-powered approach. Now, to make this more plastic, let's look at a demo. In this case, we inserted a prompt and asked the AI builder to build a shop floor application. And it immediately starts to turn this prompt into an application concept and then build the things needed for an operational app. These are user interfaces, data sources, the connecting layer, and the action flows, which means the deterministic process flows needed to go through the steps of the application. Now, the result is here within just a few minutes. The application builder built all this using the components provided by the platform within the guardrails provided by governance. What, of course, we need to point out here is this is not a finished app. This is 80% application, and the start for the final touches and tweaking in terms of data sources, in terms of data control, and in terms of twitching and tweaking the process to the maximum. Industrial orchestration platforms, they will combine this AI-powered speed that we see in vibe coding every day with the stability and governance that we need for mission-critical operations. That means they will orchestrate and integrate all those systems, machines, humans, robots, and agents that we see in productions. And on the other hand, they will provide a scalable and stable framework to do that. So let me conclude with these words. Industrial companies, they won't build fewer apps in the AI era. They will build thousands of them. The question is, who governs them? Who integrates them? And who brings them to life in operations?